Welcome everyone to my keynote on developing a scope and sequence for whole school robotics integration. This keynote will focus on some of the strategies and policies that Chancellor State College has used to build a world-class robotics program. Firstly, I will examine our current practices for building staff capacity within the area of digital technologies and how this provides scope for our future. I will emphasise our STEM approach and the how and why of robotics in relation to the curriculum and our extracurricular programs of excellence that our students engage with. I will explore further our connections to industry and how this relates to the development of 21st century skills within our learners. And then I'll walk you through the steps of developing a clear scope and sequence for robotics integration and how this can be used to form the strategic leadership within the digital technologies curriculum. Lastly, I will show you some of the work that our teachers are doing within the area of digital technologies. To give some scope to my keynote today, I would like to give a little bit of information around the background of Chancellor State College, where I'm the STEM and digital pedagogies coach. Chancellor State College is a P-12 campus on the Sunshine Coast in Queensland. The college comprises of two campuses that sit adjacent to the Sippy Downs University of the Sunshine Coast. Our current enrolments across both campuses sit around 3,000 students. We are a state school and we pride ourselves on the inclusion and the success of all students. At Chancellor State College, improving student achievement is a priority. The aim of coaching is to build capacity in all of our teachers to enable them to provide high quality teaching and learning. Our coaching program aligns with the Australian Professional Standards for Teachers, professional engagement domain, which basically describes the professional practice and professional engagement required of teachers. The coaching roles at Chancellor State College work within a GROW model, where coaches work one-on-one with teaching staff to target specific goals. Teachers negotiate regular coaching sessions to assist them in achieving these professional goals. The model is based upon the stages of gradual release and with a clear emphasis on the time for reflective practices. Additional to the GROW model, we also use and utilise the technical, pedagogical and content knowledge model to give teachers and students scope when guiding them towards the SMART goals they set. The use of TPAC has been fundamental in increasing our teachers' capacity, and it makes it really clear what the goal of pedagogical improvement will look like. For example, we will break down the functionality of an interactive whiteboard from a technical perspective to find its limitations before we would actually go ahead to create interactive resources that may use the pen, for example, for students to engage with content. The teachers are then clear on what the product is capable of before they then look at the processes that they will use to make it worthwhile in the classroom. As well as my coaching role, I also facilitate many extension programs across the P-6 campus. These include a Robotics Excellence Academy, a digital enrichment program for our prep students, and esports within our Year 5 and 6 cohort. These programs complement the work that is being done within the classroom and extend our students outwards into industry-supported competitions. Why robotics? Education, warehousing, maintenance, food and hospitality, even fashion design have begun to see the direction of required skill sets changing. Robotics has the potential to positively transform lives and workplaces. Daily, we can see the influence of automated systems. By having students control a physical robot and seeing what goes wrong, students often learn what robots can and can't do. They also learn the need for precise instructions. Teaching young students often the abstract subject of programming can be challenging. Programming is too complex for most students to grasp. Robotics, on the other hand, is a simpler and more tangible way to introduce programming to students. Robotics programs also allow students to understand how things work. Children can put together simple machines using these kits. They can set up the hardware and, again, working with the software to be able to make a robot that is working. Children can also develop their problem-solving skills when they run into issues when they are using their robot. Often they don't mind these issues because they're having fun. And this is the whole point of this era of dynamic education. If we accept the fact that all students will need robotics literacy within the next decade, but only a small portion of students are graduating with any robotics knowledge, what we are effectively saying is that we are going to graduate from high school without a key literacy we need when looking for work. Simply put, we are on the brink of a skills gap. And within a global economy, if our students lack these necessary skills to claim these new or evolving jobs, then these jobs will be fulfilled by people in other countries, states or cities. In late 2019, the United Arab Emirates signed an agreement that will see more than 1,300 artificial intelligence labs built in their primary and secondary skills across their country. If we project forward 5 years, the UAE will have a substantial advantage over other nations who have not yet adopted this type of technology and teaching. We are told time and time again that students are preparing for a very different world from the one we know. It is elaborated by the QCAA that young Queenslanders need to be innovators, entrepreneurs, lifelong learners and responsible global citizens. At Chancellor State College, we have focused on a STEM program that is built on scientific inquiry, technological innovation and mathematical computation. These three components have allowed us to target the explicit teaching of 21st century skills and to find the time to allow students to explore knowledge deeply. Robotics plays a fundamental part in the exploration, with LEGO Education robotics platforms being explored in all of the bands across the primary levels. The use of a similar solution across the year levels allows students to bring with them the experiences from previous years and allows knowledge to be gained in a systematic approach. Our robotics integration is centred around the approach of learning for the real world. Teachers are given planning time to unpack the curriculum expectations of not only their year level of instruction, but also the year level before and the year following. As a team, we have deconstructed what is new learning, what is expected from their prior experiences, and what they may be required to be exposed to make their transition to the next year even easier. This approach focuses on three specific things: the value of experience, common language, and quality products. Part of our strategic plan for digital technologies was to unpack the expectations of a student if they were to choose to explore a job within the field of computer science, engineering, or mechatronics. From working with industry professionals, universities, and local hobbyists, we've been able to identify several key concepts that would be a goal for a student leaving Chancellor State College through our robotics program. These include exposure to control systems theory, non-routine problem solving, adaptability, and systems thinking. We then began to align these goals with the Australian curriculum scope and sequence for digital technologies in the primary and engineering within the secondary. A common language was established with staff and students by the selection of Python as our language of choice. On the primary campus, this would mean that we would lead with Scratch all the way up to Year 6 to assist with the syntax understanding, and it would also allow students to see the link between text and block coding. It has been a noticeable change within the school when students progress year to year using and building knowledge with the same programming environment. This has made an additional drastic change to the ability for students to transfer from block to text. And for all the teachers of Year 7 and 8 digital technologies, you will understand my joy in this. In prep students, we are exposing them to digital pedagogies in a hand-on exploratory play environment. They are engaging with multiple different products with the aim being that they are developing an understanding of one-to-one and the idea of cause and effect. In Year 1, students begin to look at systems thinking and explore the use of LEGO WeDo kits to gain insight into basic systems and look at how these are controlled with using algorithms. In Years 3 and 5, we explore the use of sensors within system design, and students move from the LEGO WeDo kits to the LEGO EV3 robotics platform. In Years 6 to 12, we continue to explore the LEGO EV3 and the Spike Prime, as well as other robotics platforms such as Tetrix and Rev. To ensure all of our STEM units have added rigour, we have created a framework to be able to assess these units with a criteria known as our STEM scale. The scale ranges from 1 to 4. With a STEM integrated unit, for it to reach a 4, teachers need to ensure that the unit has a real-world context, it has link between at least 3 key learning areas, and it has an incursion or an excursion to be able to build experience. We have often found that we can address gaps in knowledge by teaching content. However, we cannot address gaps within experience without giving children opportunities for those experiences. In this unit, as an example, we see the year ones going on an excursion to sea life at Mooloolaba. They get to see firsthand some of the animals that they will further investigate within their science and technology units. They'll speak with professionals in regard to the external features of some of these animals, and they will see the environments and the enclosures and how these have been built to basically meet the specific habitat needs of that animal. As a social context, we often have in our units feature some sort of sharing. So we have found that this is probably the most important part of students gaining information, is their ability to then share that information with the broader world. We often use English or HASS as a social context for learning, as this allows students to be able to showcase what they have learnt and feel included within their community. Within science, students investigate a local beach area that many would already have personal experience with, and then they investigate some of the local creatures within that area, such as seahorses, turtles, stingrays, crabs and sharks. Within technology, students build and create working Lego models of the same creatures to mimic their external features and also the movement of these animals so they can see what they look like. This allows students to use key terminology that they learnt within science to be able to label some of the parts they are constructing on their animal. This gives students a rich understanding of not only the key vocab associated with the units, but also how these animals move and how they are structured to be able to live within the habitats. Within these units, both science and technology, students are constantly using some of the mathematical components from their term as well. They investigate shape and look at the different shapes and how these make up the animals within their Lego models. And they also use informal and formal points of measurement when they start to talk about the size of different creatures in relation to the habitats. And they also investigate some distance when they start to talk about their Lego models and how they travel when they're using the coding software within the Lego WeDo package. The big picture for us is that by the end of a unit, we don't necessarily want students to have a bunch of memorised facts or the fact that they've done some sort of test to show us their knowledge. What we're really hoping is that the students will be able to share their rich knowledge with their family and friends. What we often see is that when students visit these areas where they have exposed an interest in and they've had this experience with, they then have this rich layer of knowledge to be able to share. I'd just like to open up now to questions. I know that there's a lot of different products that we use at our school and lots of different approaches. So if you have any questions about that, you can definitely drop them in the chat box and I'll answer them now for you as well. If you're interested in seeing some of the solutions that Lego Education has, I know they do have a virtual stand here today, so you can definitely go and look at some of their packages. And talking to them today, I know that they've also got a new product being launched, so they're pretty excited about that. So definitely go and check them out. Thank you.